change this number. So here's our loop. Delay, 50 milliseconds. See, it just waits between the pings, which there's about 20 pings per second. Sure, that makes sense. 29 milliseconds should be the shortest delay between pings. All right. Not necessary information, but I appreciate it's there. Serial.print ping, and then it prints this, sonar.ping.cm. So I don't know exactly what that is, but then reading the comment, sends ping, gets distance in centimeters, and prints result 0 is outside set distance range. Okay, so it's using this library, it's using this object that came from the library, and it's calling this ping.cm method. So if I go in and I Google this library, or I go through tools and find the library again and go to more info, I can probably understand exactly how this method works, but here already just looking at the program, I know how to use it, right? I set up this sonar object, and then I just call ping.cm, and I've already given it these arguments. It'll just automatically give me the distance, right? So rather than doing all that math and having all that code, boom, one line gives me exactly what I need. And that's the power of libraries, right? It's a lot less code that you're writing that doesn't need to be rewritten because someone else has already wrote it before and wrote it better. And this will probably be more accurate. And then it just prints out CM, and then it just loops over and over again. So when I tried to upload this last time, I got some errors. A lot of these you're going to look at, you're going to be, what the heck is that? It's a register. You don't need to know what this is. We're just going to ignore it. But you're going to notice that all of these errors are coming from the new ping library. So I didn't go through and debug this. My guess is that there's something going wrong with the library now. So if I really wanted to pursue this, I would probably throw something like this into Google and try to go from there. But for my sample program, I decided it didn't need to be this accurate, and I'm just going to go with the one that doesn't require the library. The other part of it is the servo motor. So I also have this, a servo test, and I like also for every single one of my modules I'm using to just test that one module on its own and make sure it's working before I try to implement all of them. So for servo, here we have a servo library, very similar to new ping library. You just got to go get it if you don't already have it. And then remember to include it at the top so you can call it. Servo, my servo creates a servo object to control servo. So just like the new ping library, usually when you use a library, they just have one master object that you create, and then it handles everything from there. So I know for servo specifically, you can just create another object. Like if I just went servo 2, well, now I have a second one that I can now call all the same methods I could call in the first one, but it would be a separate servo motor that I'm controlling. So if I needed 2 servo motors, I'd write both of these, and then I'd also name them so it gives me more information, but we're not doing that for now. 12 servo objects can be created on most boards, and that's usually because I think it might be a thing with pins. I'm not exactly sure, but it's also just, hey, thanks, good to know. If I have a project where for some reason I would need 13 or more servos, I'm going to have a problem with this library, and I'm going to need to find a solution. Int pause is equal to 0, variable to store servo position. Thank you. It's the same thing. If you're writing code, comment it, because if you're showing it to someone else, they need to understand it. And when you work on one of these projects and you come back 6 months later and you don't know what the heck this is for, this nice little comment will save your life, right? So setup. This is the object from the library. We're going to call a method from the library, attaches the servo on pin 9. Cool. So the servo just knows that it's going to be communicating with pin 9. So when I wire my servo, I talked about earlier, there's going to be power, ground, and then an information pin. So I'm going to wire it to the 5 volts, wire it to the ground on the board, and then pin 9 is going to be the data line. And then going in the loop, this is the code that's over and over. Hopefully we've all seen a for loop before. It's going to take position from 0 to 180, and every single time it does that, my servo.write position, what does that do? Tells servo to go to position in variable pause. So something that you're not going to know immediately that I might as well just throw out there. There's 360-degree servos and there's 180-degree servos. So 180-degree servo, which is what we're working with here, you give this write a value of 0 to 180, and it just goes to that angle. So 0, if 0 is to the left, then 180 would be boop, 180 degrees all the way to the right. And you can do any value in between. As you can see, this hits everything from 0 to 180. And then writing more than that, it depends on the behavior of the library. I don't know, but obviously it won't be able to physically turn that much. 360-degree servos, you don't give it an angle because it can spin forever. You instead give it a speed that it turns at, so it can go forwards and backwards. And then for this, it waits 15 milliseconds. So the servo physically needs to move. If you send it another instruction before then, it's not really good for the servo. So you're just going to delay 15 milliseconds just so it can actually get to that position. Obviously, it's not going very far. It's moving 1 degree. So this for loop is going to take the servo from 0 degrees and slowly move it to 180 degrees. And then this is going to do the opposite. It's going to take it from 180 and slowly move it back all the way to 0. And then this thing is just going to loop over and over and over again. So I don't want my servo for this program to slowly move back and forth. So I can delete a lot of this, but I just need to know that this myservo.write, if I want it to go to a specific angle, this is what I use. I put the number right where pause is. I can just delete it, write something else. And I also need to delay at least a little bit so that the arm can actually get there, right? So this line is key, the delay is important, and this line is key. So if I'm going to use my servo in another project, I need to know that these lines are the important ones. And if I copy and paste it, I'll probably try to include the comment as well so I don't have to rewrite it every time. So why don't we go to what I actually did for the sample project here. So you'll notice I actually just copy and pasted the distance sensor information, and then I just also included the servo library, the servo object, this int pause, and then we can just see all these lines are just the setup from both of the two earlier projects I was working on. And going through the loop, it does all of the information it needs to get the distance. It still prints the distance. I thought that would be helpful to just kind of make sure it's working and that it's going smoothly and it's easier to debug. So if I was looking at this and there was some error going on, I'd try to still look at the serial monitor, and if it's giving me really whack values, then I know the distance sensor's not working. But if it's giving me good values that sound correct, if I'm about 10 centimeters away from my door and it's telling me 10 centimeters, then I probably know my error is with the other parts of my program. It's going to be with my servo. So then I just have this one line. If distance is less than 180, my servo.write distance and then delay 300. So it's kind of a longer delay, but just hopefully we're comfortable with what this code means. But thinking about it in the real world, if the distance that the sensor is giving is less than 180, it's going to move the servo to a corresponding distance. So if something is greater than 180 centimeters away, it's not going to change anything, even if it's sensing it, even if it's 200, even if it's 300. But as soon as it gets in this range, it's going to snap the servo to this position. And then I have my delay here. I could choose to only delay it when the servo moves, but I also want this delay here so it's not completely running me over with telling me what the distance is over and over and over again. So I've successfully taken out the key parts from 2 different programs and combined them into a new project. And the project isn't that exciting, but I just wanted to get something bare bones together to kind of show you guys. And then as you can see here, this logic isn't from the servo code. In there, it just had the for loop instead of this if loop here. So once you just have these variables and you can keep track of what they are, then you can use a lot of your programming skills that you already have about certain logic to kind of come up with cool examples of how you want to use it. So maybe another way to use it is if the distance is less than 100, you set it to 180, and otherwise you set it to 0. So the servo will move all the way over if you put your hand over it, for example. And then when you move your hand, it'll move all the way back. So that's just another logic you could do. You can obviously think of a bunch of other things, but I'm glad that I at least got to show you a quick one-off project.